What is a neuron? A neuron is inspired by a natural neuron present in a human mind. These natural neurons, with which a natural neural network is composed, are useful for taking in information, processing, and transmitting it further through layers and layers, or rather, a network of such subunits providing, transmitting, and processing information. A neuron, in fact, is the same. It's inspired from this natural neuron. Like a natural neuron has its own dendrite, nucleus, axons, and synapses, a neuron itself has its own inputs, weights, biases, and outputs, and also activation functions to process and rather change the input and put out the output as a reflection of its nature. To understand more of what a neuron is in depth, think of a bus in a network of buses. A bus has its own start point, end point, pickup, drop, and a route forms an individual entity in a whole entire network. Its contribution to a whole larger network is quite essential to have an up and good running bus network in a city. In the similar way as each bus is important for commuters to travel from one place to another and for a smooth running of a bus network throughout a city, individual neuron is important in an artificial neural network. When we talk about artificial neural networks, there are layers and layers of neurons stacked on each other. A neuron becomes a fundamental part wherein it accepts the raw input. Take any data set, for example, a stock prediction, a business data set. It takes that raw input, processes it further, and passes on the processed output as an input to the intermediate neuron present in another layer. Similarly, neurons in specific layer contribute for a whole throughput or output of a particular layer to the next intermediate layer. Let's talk about the components of neurons and the mathematical functions. A neuron has inputs. These inputs could be anything. If this neuron is present in a layer which is an input layer, there could be a raw input. Imagine you stock data, the price, the profit, the factors that are responsible for your business could just be an input to this neuron. By the way, a neuron is also called a perceptron. This inputs to this neuron in an input layer, in a hidden layer, and an output layer would tremendously differ. If these are the inputs of a particular column or a characteristic in your data set, in an input layer, then they would be different in an intermediate hidden layer. They would be an accumulated sum, or rather, a sum of whole subnetwork, a sum of earlier present neurons outputted via a neuron as a cumulative sum. If a neuron is present in a hidden layer, in that scenario, the input to a particular neuron could be the input via its connections to the previous neurons, and these neurons could have the input as a cumulative result of the previous subnetworks in an artificial neural network. These neurons then in an output layer would have the final summary of your artificial neural network and would just use an activation function to output what you really expect, why that is to be predicted. A neuron has its own components. So X1, X2, X3, and so these are nothing but the inputs to the neuron. W1, W2, nothing but the weights to these inputs. We would have a detailed video on what weights and inputs are, but just imagine weights are nothing but kind of importance or weightage that you give to a particular input. Imagine a business case scenario where a particular characteristic or column needs to be more profoundly thought on for a particular problem statement. In that case, that column or that characteristic would have extra weightage than the other ones. In this scenario, this weightage is something that has been adjusted with backpropagation algorithms. We're going to have a deep dive into them as well. Apart from this, you can see one more term that is present there, the bias. The bias is responsible for biasing the input that has been provided. As the word suggests itself, it is responsible to give weightage to a neuron's output. Imagine the bias which ranges from 0 to 1 is going to give certain importance to your neuron. In the sense, if it's 0.5, imagine your neuron is a mid neuron. So whatever your output is, it's been influenced by a 0.5 factor of being biased towards what this neuron is trying to predict in a whole neural network. But if this neuron is very close to 0, imagine whatever this output is going to be outputted out may not be that kind of weightage holder. So we talked about weightage of inputs, but bias says what is the biasness of this particular neuron in a whole neural network. How is the output to a neuron received? The inputs are multiplied by the respective weights x1 with w1, x2 with w2, and so on. These weights are then been added to a bias. The bias and the weighted sum of this input is then given as an input to an activation function. We are going to cover a lot of activation functions with thorough visualizations in the next lectures. But in this lecture, an activation function is something that is responsible to change the way the input is seen. Imagine a linear input which grows 1, 2, 3, 4, 5. But this linear input put up to a mathematical function will produce a certain output. Imagine it's been put up to a ReLU function. A ReLU function, which is a rectified linear unit function, gives out the probable value of max and 0. So in this case, it would just print out the actual value. Otherwise, it would print out 0. So in this case, we have lots of different functions, may that be sigmoid or leaky ReLU or so on. There are lots and lots of activation functions. They change the way your input is being processed. Each activation function has its importance. How do you decide which one to choose? Well, we are going to explore that in our videos of activation function. These activation functions are responsible for processing this cumulative sum and outputting a value which is determined as the output of a neuron. This neuron's output through layers and layers of artificial neural network is transformed and taken ahead. And that's how a neuron contributes individually to a neural network. Thank you. For more such videos on depth and visualization, please subscribe to the channel In Depth Academy.